Hello everyone, my name is Joe Grandja. I'm the lead on the Spring Authorization Server project, and we're going to be talking about configuring and extending Spring Authorization Server today. Thank you very much for coming out. We really appreciate your time. This talk is going to have three parts. The first part is we're going to actually do a demo on the default configuration. We're going to give a high level of what the default configuration is. This essentially is the getting started experience. And then the second part is we're going to have a series of demos on how we could customize the configuration of Spring Authorization Server, common configuration scenarios. And then finally, the third part is we want to be able to add our own features on top of Spring Authorization Server. So we're going to show how we can extend Spring Authorization Server, and we're going to use the use case of adding a new authorization grant type. So let's get right into it and do our first demo on the default configuration of Spring Authorization Server.
Hey everyone, my name is Steve Riesenberg, and I work on the Spring Security team on Spring Security and Spring Authorization Server. Let's go ahead and get started. I'm going to head over to the project page here, and we can see that Spring Authorization Server has gone 1.0 very recently, and so there's the version number right there at the corner, but we're going to jump right in and get started using this link. From here, we can see the Getting Started page suggests that we can go right over to Spring Initializer and create a Spring Boot application to get started. So I'm going to head over there and do that now. So we're just going to accept the defaults here. We're going to be on Spring Boot 3.0. We're going to use Java 17, and I'll be using the Gradle as the build tool. So let's add some dependencies. I'm going to start with Spring Web and then Spring Security. And with that, I'm just going to generate this project, download it, and I'm going to launch this in my IDE here. Once we do that, we can open up our build tool, or build.gradle, and add a dependency here. So I'm going to head back to the Getting Started page and grab the Gradle dependency for Spring Authorization Server 1.0. I'm going to add that and re-import. And as that's rebuilding, let's go down here and grab the security config for Getting Started. And we're just going to take this in full. And if you're curious about all of the components and what they do, we're not going to have time to go over each one here, but you can find all the links to the relevant documentation down here on the Getting Started page. So if you want to learn about Spring Security and the protocol endpoints, all of these things are linked here. I'm just going to go ahead and paste this in to my project. And let's talk about a couple of these components here. The first one is the authorization server security filter chain. Now this is just setting up the default protocol endpoints with this apply default security method. And from here, we can see that we're also enabling OpenID Connect. And that's going to be important because we're going to be using OpenID for all of the remaining demos. If we scroll down here, we can see the default security filter chain. And this is just Spring Security's default filter chain. And so this is going to set up our form login authentication mechanism. And so we're going to be using one default user. We're just going to create a user and password with a user detail service in memory, but of course you can customize this to provide access to your own user store. And the last and most important thing that we're going to look at here is this registered client. Now this registered client matches our default configuration. And from here we can see that we're using OpenID Connect, we're using the OpenID scope, and a couple of redirect URIs. And we're not going to customize any of this now. So with that, I'm just going to add one additional configuration, which is I'm going to set port number 9000. And then the last thing that I want to point out here is I'm enabling trace logging for the Spring Security package. And this allows both Spring Security and Spring Authorization Server to print messages to the console and really show you what's going on if you want to troubleshoot what's going on behind the scenes. With that, let's launch the demo and start our default flow here. Now I already have a client running on port 8080, and so we're going to hop over to my browser and launch the flow from that client that we're running. This is the default client in our official samples repository. So if you're following along, you can run that messages client sample to get started. So this immediately redirects me over to the authorization server to log in. So I'm just going to use the default password and the default user that we set up earlier. And from here, Spring Authorization Server has generated this nice consent page. And so it's asking for messaging client to access my profile. And so this is the OpenID flow in action. So I'm going to go ahead and consent to the profile scope and hit submit. And from here, we're taken back to our sample client, and we can see a couple of flows demonstrated here. And we'll just be focusing on the authorization code flow from here on out. So I'm going to click on this link. This is going to take me back to Spring Authorization Server with another consent screen. And this time it's asking for 2 custom scopes. And so I'm going to go ahead and grant consent to that and submit. We're going to be taken back to the client. And you can see here now that the client is able to access resources from a sample resource server. And that's it. That's the getting started experience. It's that easy. And from here, we're going to jump into a series of demos that goes deeper in configuring Spring Authorization Server for different scenarios.
Hi everyone, I'm Laurentiu Spilca, and today I'm going to show you how easy it is to customize the new authorization server framework. We will work on a couple of examples, and then you will continue with some more other examples. I will show you how to add custom claims to the JWT token produced by the authorization server, and then I will show you how to create a custom validator for the authorization code request. Let's start with the first one. This one is at a glance of only adding a bean to the Spring context. So to add custom claims to your JWT, you need to add a bean of type OAuth2 token cost customizer. I'm going to use a generic type JWT encoding context. And of course, I'm going to use the bean annotation above, so this ends up in the Spring context. Now, if you will take a look inside this interface, you will see that it's a very simple functional interface, so it's straightforward to use a lambda expression to implement it. And we can use the context now to add whatever claims we want. So I can add a simple claim like, Luke, I'm your father. Or for example, I can add the list of authorities if I want to have a custom claim for that. So claim, and from the context, we get the authorized scopes, and then you can add as many other claims as you'd like. It's the only thing we need to do is this, and I will prove you that this really works. I will now restart the application, and what I did, I added a breakpoint where the token is produced, so I can copy the value, and then we can investigate it together in JWT IO. So once the application restarts and I will be able to use the new code I've added, I will call the client. The client will send the request to the authorization server, and then the authorization server will stop in the breakpoint that I've added. Let me see if this actually already started. Okay, now it happens. And we should be able to go to our browser, and I will use the localhost 8080 client I have. It's going to redirect me so that I can log in. Okay, once more. I will use the user and password that we have defined in the authorization server. I have to, of course, accept the consent, and then I should see that the execution pauses in the breakpoint. And I'm going here, I'm seeing the access token. I copy the value and I will put it in JWT-IO. And we can see the couple of claims we have added. So both of them are here. So this is easy, isn't it? Now, very easy is also to implement your own validator for the authorization code request. Why would you do that? For example, the OpenID specification doesn't allow for the usage of localhost. But many of us, at least in the development environment, we would like to use localhost. So you can't do that by default, but you can always implement a custom validator if you really want to use localhost. Let me show you how to do that. To create a custom validator, I will separate it in a class. So let's just create a new class for that. We can call it custom request validator. We implement the consumer functional interface. And we will use a generic type Auth2 authorization code request authentication context. Naturally, I need to implement the abstract method. And that is also where I will define the logic. So in the context, from the context, I can get all the information I need, like the authentication, for example. This authentication is in fact of type Auth2 authorization code request authentication token. So let's take it as its defined type. We also need the registered client, and we can get that, of course. And we want to validate the provided redirect URI and make sure that our validator accepts localhost. So I need the URI as well. So let's take the URI from the authentication. Now I can simply say something if the URI doesn't exist in the list of the URIs provided by the registered client, throw an exception. So I allow all the URIs, including localhost if I have it. So if the URI isn't in the list of the registered client, then I will throw an exception. I will first define an error with the proper error code. Say invalid request, for example, and then throw a new Auth2 exception. With that error, eventually you can put the authentication or you can skip it, like I did here. And that's a very simple custom logic for a demonstration. Now, let's plug the custom request validator in our configuration. I'm going to security config back, and I'm going to add the authorization point endpoint configuration. And I'm going to go through the entire list of authentication providers. So let's extract this into a method to make it easier. So again, I have a consumer. I will return the authentication providers. But before I return them, I will go through each one of it. And then if it is the type authorization code request authentication provider, then it means I need to apply my custom request validator. I create a new instance of type custom request validator. And I apply it on my authentication provider using the set authentication validator method. Of course, we can clean up a bit the code by using the new syntax for the instance of. And that's it. So I told you it will be short and easy. We will end now, but you will continue with some more demonstrations. Thank you.
All right, let's jump back in here with the next demo. We're going to be configuring Spring Authorization Server to require PKCE, or proof key for code exchange. So there's this additional client setting that we can set up here called require proof key, and I'm going to set this to true. What this does is it instructs the authorization server to require PKCE parameters from the client during authorization. And so if I were to restart the authorization server with just this change, we would see that we're going to get an error, and that's because my client isn't sending a code challenge with the request parameters during authorization. So let's try that out quickly here. So I'm going to launch the same demo as before on the client. And when I do that, I'm redirected to the authorization server, but we get an error here. And so let's check out the console to see if we can figure out what's going on. So we can see, because we have trace logs enabled, we have this nice stack trace here, and we see that the code challenge method isn't required. But if we wanted to investigate deeper, we could actually click on the authenticate method for authentication provider here and jump right into Spring Authorization Server's code. And we can see that, in fact, it is throwing an invalid request error. But why? We can see that the code challenge is being accessed by Spring Authorization Server from the request parameters. And if it doesn't find that, it checks to see if the require proof key setting that we just set is true. If it is, then in fact, we're going to get this error. So we can actually configure the client to send PKCE parameters. And when we do that, our client will send the code challenge and the code challenge method, and the authorization server's validation will be satisfied. And so we'll actually see a successful flow here. So let's go ahead and try this. So if I set this up, I now get a redirect to the authorization server successfully. So we know that we're getting a little bit farther and things are working. But if I log in with the sample user, I'm going to pause on the consent screen. And we can investigate the URL here. And I know it's hard to see on the screen, but if you check it out and run the sample yourself, you'll see that the code challenge and code challenge methods are being sent by my client. And so now we are actually enforcing PKCE for a confidential client. So I can finish this flow out here. But what if we wanted to take this a step further? What if we actually wanted to configure a public client to use PKCE? Let's take a look at what that would look like in Spring Authorization Server. So the first thing I'm going to do is rename this existing client to confidential client. And then we're going to copy it and create a new one for our public client. So I'm going to swap a couple things out here. We're going to call this public client and change the client ID. I'm going to get rid of client secret. I'm going to set the authentication method to none and just get rid of a couple of grant types that we're not going to use here. And then I'm going to remove the redirect URI that we're not going to use and set the remaining one to be the redirect URI of our Angular client. Now, I've set this client up ahead of time, so let me go ahead and start this up for you. And if you're interested in following along, you can check out this client in the commits that we'll share with you at the end. So as this gets started, normally I would be able to add this to the list and restart the authorization server, and everything would be fine, except if you're following closely, you'll know that a public client that's running on a different domain or port needs CORS enabled in order to be able to authenticate or communicate with the authorization server. So I'm going to enable CORS, and I'm going to do this for both filter chains. And then the last thing that I'll do here is just add an additional bean beyond our getting started example. And I'm going to configure the allowed origin to that same port number that I'm using for my Angular client. So I'm just going to add a couple of imports here. And once these imports are added, then we'll go ahead and restart the authorization server and see this in action here. Let me just check that everything looks good. All right, so let's restart. And I have this extra client that's running on another port, so let's launch my browser and try this flow out one more time. So if I go to port 4200, I have this new client. It looks very similar to the default sample that you're used to seeing, except I have this login link at the top. So I'm going to follow this, and we're going to move into an OpenID Connect flow with a public client here. So similarly, I'll log in with the same user and password. And again, if we investigate the URL here, we can see that we have a code challenge and code challenge method parameters in the URL. And so the flow would continue as normal. Okay, so from there, we're going to reset and jump into the next demo where we're going to investigate what it would take to configure Spring Authorization Server for opaque tokens. So let's do that. I'm going to reset my commits here. And I will have to restart my client. So I'm going to do that while we're waiting. And then we'll go ahead and jump into configuring authorization server for opaque tokens. All right. So we're going to add an additional setting here for our builder called token settings. And so we can pass a token settings builder into this. And we have a couple of options when we want to configure token settings. One of them is going to be access token format. And the default for authorization server is self-contained. And that would instruct the token generator to provide a JWT to our client. But if we change this to reference, it actually instructs the token generator to generate an opaque token. While we're here, let's go ahead and add a couple of additional settings. So I'm going to add an access token time to live, and I'm going to set this to an interesting value of 60 seconds. And this is very short, and it's going to force our client to refresh the token every time. And then we're going to set the refresh token time to live to a really long value, like 365 days. And so we can investigate what happens when we do that. Now, at this point, if I were to restart authorization server, I would hope that everything works, except we have one problem, and that's that our OpenID Connect flow is actually still using JWTs. And so in order to clean this up, I'm going to split this client into two pieces. And the second one that I'm going to create above here, we're going to rename to OIDC client. So this is going to be a client dedicated to OpenID Connect. So I've changed the client ID and the secret here, and I can just clean up a few things like the authorization grant type client credentials we won't be using, and this extra redirect URI for the OAuth2 flow we won't be using as well. And then the last thing I'll clean up here on this one is the extra scopes, because OAuth2 will be using those, but we'll just be using OpenID and profile here. And then we'll go back to the default token setting. So I'm going to remove this as well. And so lastly, I'll just clean up the second client that we have here and get rid of this messaging client OIDC redirect URI. So we're just using pure OAuth2 here. And then we'll get rid of these two scopes. And with that, I'm going to add this to our list. And we're going to try this out. So let's restart authorization server one more time. And then let's see if we're seeing opaque tokens. So if I go back to my browser and launch the flow once again, we're taken back to the login page. And so everything looks fine and normal from here. But if I get in here, I see now that we have this OIDC client. So we do have two different clients, and this one is dedicated to OpenID Connect. So let's continue that flow. So we get back to the client, and now when I click on this link, we're going to be taken through a pure OAuth2 flow, and we can see that the messaging client is in fact being used, but we can't see that it's using opaque tokens. There's no way to really tell because it is transparent to the client and to us as a user. So how would we investigate that further? Well, if you check out the commits at the end, I've added an additional endpoint to this client application in our sample here, and it just prints out our refresh token and our access token. And I want you to notice one thing. If I highlight this here, this line is going to change every time I refresh the page. And that's because, if you remember, I set the access token time to live to 60 seconds, which is so short that it actually matches the clock skew of our client. And that's forcing a refresh on every time I refresh this page. So we're getting a new access token using the refresh token. So let's take a look at this access token that we have here. And we're going to use the introspection endpoint of Spring Authorization Server to take a look at this. So I'm going to say introspect, and I'm going to pass the token as a query param here, which I haven't set yet. So I'll set that as a variable in just a second. And I'm going to set my client credentials as well. So I'll play this. This is going to get an error here, or actually an active false. Let's just export this token to the command line here and replay this request. And so I should see that this access token is still active. It'll expire in just a second, but we see some claims very similar to what we'd expect if we were using a JWT. But this is an opaque token. There's no period characters that give us a clue that this is a JWT. So it's in fact opaque. And if we wanted to, we could revoke this token. So let's just change introspect to revoke here and run this request again. And so if I replay the introspect request, now I see that active is false. But wait a minute, my expiration time on that token was so short, it probably just expired. So if I go back here to my client again and refresh, I can see that I'm still getting new access tokens. So let's imagine for a second that this refresh token was leaked and this is the thing that we want to shut down. So let's revoke this token instead. So I'm going to export this to a variable on my command line here, and we're going to run the introspect request one more time. This time we're seeing slightly different claims coming back, and that tells us that we're introspecting actually a refresh token with just an expiration and issued at claim. But we can actually revoke this token as well, so let's try that. So if I revoke the refresh token and introspect it one final time, I'll notice that active is false. That means we've shut down access to this from the client. And so if we detected that there was a leak in that token or something like that, we can shut that down at its source. If I go back to my client and refresh this page one more time, I actually get an error now. And that's expected. We know that we just revoked this token and we might want to add some nice error handling to our client. But if you're seeing this for the first time, you might wonder what's going on. So let's actually head back to our client application and take a look at the logs here. The client application just sees some kind of generic error. It says invalid grant. That's not very helpful, but we know that we've enabled trace logs on the authorization server. So let's head back to the authorization server and take a look at what we can see there. So we see the same error on authorization server in the logs of invalid grant, but we now have a stack trace that we can jump into. So I'm going to click on the authenticate method for the refresh token authentication provider. And let's take a look at the code here. So we can see that authorization server is accessing the refresh token and checking to see if it's active. If it's not active, it's returning this invalid grant error. So that is what we expect. Since we revoked the token, we know that it's inactive. But that just gives you an idea of how you can use trace logging with authorization server to debug some of these common errors that you might encounter on the client. And so with that, that's all we have for these demos. We've seen and configured Pixie for a confidential client. We've configured it for a public client. And we've even seen opaque tokens in action with Spring Authorization Server and learned how to introspect and revoke tokens as well. And with that, we're going to go to the last section of our talk here and look at extending Spring Authorization Server with a custom grant type.
Okay, so we actually had quite a few demos there on how to customize the configuration of Spring Authorization Server. Let's take that to the next step. Now, I want to be able to add a new feature on top of Spring Authorization Server. And a common question that comes around is, how could I add my own authorization grant type? So we're going to do a demo here on adding a new authorization grant type on top of the default features or the default grant types, and providing an implementation of the JWT authorization grant, RFC 7523. From a very high level, this specification defines a token exchange pattern. You have an existing JWT and you could exchange it for another JWT. A typical use case would be a client has an access token, has higher privileges, but it wants to call a resource server with an access token with lesser privileges. So you could use this token exchange pattern by passing that higher privileged access token, and the access token that comes back would have lesser privileges. So it's a common use case. Now, before we actually get into that implementation and show how to configure it, I want to actually go through the request and response processing flow for default OAuth 2 endpoint. So this is a common pattern for all the OAuth 2 endpoints that come packaged out of the box with Spring Authorization Server. Whether it's the authorization endpoint, token endpoint, the same common components apply. And these are the extension points, the blue colored components. Now I'm going to walk you through a request response processing flow for a protocol request flow, and I'm going to describe the responsibilities of each of these components so you have a better understanding how you could enhance the behavior or add to the existing behavior. So let's say we have a request coming into the OAuth 2 endpoint. It's going to delegate to the authentication converter. So the authentication converter, the responsibility of this component is to determine the request that's coming in. Let's use an example because it's probably going to be a lot easier. Let's say it's a token request, an access token request coming to the token endpoint, and we're going to use the authorization code grant. All right, so this authentication converter instance will look for the grant type parameter. If it's authorization code, then it will process it, and its responsibility will be to extract all the parameters, the code, the redirect URI, client ID, and so forth, and then encapsulate it into an authentication instance for the authorization code grant. The next step would be is it would pass this authentication instance to the authentication provider indirectly. The authentication manager composes one or more authentication providers, and eventually the authorization code authentication provider will get called with this authentication instance. Then its responsibility obviously would be to authenticate the authentication instance. In this case, it's the authentication request. So it'll authenticate the redirect URI, ensure the client's authenticated, and so forth. If it's successful, then we go into the response processing flow, and it delegates to the authentication success handler and ultimately returns the access token response. If the authentication fails, delegates to authentication failure handler, and a standard OAuth 2 error is returned. So this pattern here is the same across the board for most of the OAuth 2 endpoints: authorization endpoint, token introspection endpoint. However, it's not the same for all. Like, for example, the JWK set endpoint, it's a pretty simple endpoint. It's open to any caller. It doesn't authenticate. It just returns the public keys. So these components don't apply. But most of the components or the endpoints have these common components. So these are your extension points, the blue colored ones. So what do I got to do now? If I want to implement my own authorization grant, specifically the JWT authorization grant, what do I need to implement? Let's jump to that next screen here. So as you can see, the orange colored components, I got to implement the authentication converter and the authentication provider. The authentication converter, similar to the authorization code grant, it's going to look for the grant type parameter. It's going to look for the JWT bearer URI as the value. If that's the value, then it'll process, right? Then it will extract the assertion, which is the JWT, the assertion parameter, the scope parameter, and then it'll encapsulate that into a JWT bearer grant authentication instance. It will eventually get called to the authentication provider here. So this needs to be implemented. Responsibility here would be to validate the JWT assertion. Does it exist? Is it associated with an authorization? And a number of other validations. Now, I don't need to implement the authentication success handler or the failure handler because it's a standard access token response or a standard OAuth 2 error in case of failure. So for the OAuth 2 token endpoint filter, I'm only adding an authorization grant. So it's just an authentication converter and authentication provider. Okay, now how do I actually plug this into the configuration? Let's jump to that next. Now we'll go to our security configuration here, and I'm going to make this a little bit bigger. Now, the OAuth 2 authorization server configurer, this is the main entry point into configuring all the endpoints that come with Spring Authorization Server, whether it's the authorization endpoint, token endpoint, and so forth. Now, we're adding an authorization grant, so we're going to be configuring the token endpoint, as you can see here. And all we got to do is pass in our two implementations, the JWT bearer grant authentication converter and the provider. And we pass it into these configuration parameters within the security configurer. And that's it. Like, we've literally enhanced the OAuth token endpoint filter by adding support for the JWT authorization grant on top of the existing support of authorization code, client credentials, and refresh token. Now, the only other thing that we need to do is we have one client configured here, messaging client, standard client that comes with the sample. The only other extra configuration is this client, we want to be able to allow this client to perform the JWT bearer grant. So we're going to configure it with the JWT bearer authorization grant. If we didn't do that and the client tried to perform a token exchange, it'd be rejected. So that's the only extra parameter. Now, let's prove that this is actually configured and it's working. I have a very basic test case. I have this token exchange pattern set up where first I'm getting the JWT using the client credentials grant, and then I'm doing the exchange using the new implementation of the JWT bearer authorization grant. As you can see here, I set up client credentials, I'm requesting message read, message write, and then I'm doing the token exchange here. The grant type is JWT bearer. I'm passing in the access token from the client credentials grant. And then you can see here, I'm only requesting message.read, right? So I'm ultimately requesting an access token with lesser privileges, back to that use case I was talking about earlier. So let's actually run through this sample. We'll take a look at the JWT from the client credentials grant, and then we'll look at it as well after we do the exchange. So I just ran this test here. Now we have our access token here from the client credentials grant. Let's pop this into JWT here and let's take a look at it. So as you can see here, the scope here is message read, message write. That's what we expected. Now if I let this run through, right, now it's going to perform the token exchange, and then we're going to also take a look at the access token there in JWT, and we're expecting it to be called, as we can see here. So we have the JWT bearer grant authentication converter gets called, so we know we've plugged it in. And there's some basic things we got to do here. We obviously got to extract the required parameters for this specific grant flow. We got the assertion, we have the scope, and then we're going to encapsulate that into the authentication token, right? Then we're going to let this run through. We're expecting the authentication provider to get called, and it does. Here's the authentication token. And there's a number of things here that are happening. You could take a look at the commit on your own time, but this is a full implementation here. But obviously, we have to validate the JWT, and then we're going to take into account the scope parameter that's coming in. And then ultimately, we're going to create a new JWT that looks very similar to the one that's coming in, but we're going to account for the scope parameter. So I'm just going to let this run through, and then we'll take a look at the access token here, and we're expecting it to have only the one scope. Let's take a look at that. I'll paste it in here, and there we have it, message.read. So that's the demo. That was pretty simple. We provided a couple of implementations, the authentication converter, the authentication provider. We plugged it in via the token endpoint DSL of authorization server configurer. And that's in a nutshell how you would add a new authorization grant type. And there you have it. So that concludes the last demo. We've actually demonstrated how we could add our own authorization grant type. It's pretty simple. We added authentication converter, authentication provider, added it to the token endpoint security configurer, and there it is. And we're just going to jump to the last screen. So you have a link there for the Spring Authorization Server GitHub project and the demo branch with all the codes. Please take a look at it. Thank you very much. We really appreciate your time today. Thank you.